Hello dear student, welcome to new session of your current electricity chapter. In this session we'll discuss about power. In last topic we'll discuss about the heat dissipated by resistor, which was given by Joule's law. It is H is equals to I square RT. This is our first law. With the help of Ohm's law we'll discuss as V is equals to IR. So I is also write as V by R. So we can write here as V square by R square into R into T. So 1R get cancelled. So it is V square by R into T. This is second equation, or we can say second formula, which is used under the process. And third was as we know, if resistance is not given, so V by I can be write as instead of R. So H is equals to I square. Instead of R we can write V by I into T. 1I get cancelled. So I is equals to VIT. This is our first equation of Joule's law of heating, second formula for Joule's law of heating, and third formula Joule's law of heating. These all equations are basically related to resistor. The resistor always disappear the heat, or we can say resistor disappeared the heat by following equations. It is H is equals to I square RT, or we can say V square by R into T, and H is equals to VIT. Now write down next topic. It is power. Power. Write down next topic. Power. So power is, my dear student, rate of doing work is called power. We all know about power. Power is nothing but rate of doing work with respect to time. Rate of doing work with respect to time is called power. Rate of doing work with respect to time is called power. So the formula of power is equals to work upon time. Now see, my dear student, in physics we have a concept called if the SI unit of two different quantities is same, then we can replace the quantities. I am repeating once again. If the SI unit of two quantities is same, then we can replace the quantities. So see here, my dear student, the SI unit of work is nothing but joule, and SI unit of time is also called second. So joule per second is nothing but watt. So the SI unit of power is watt. Now see, the SI unit of work is joule, and the SI unit of heat is also joule. The SI unit of work is joule, and the SI unit of heat is also joule. So instead of work we can use heat as well, because we know that SI unit of heat and work is same, and if the two quantities SI unit is same, then we can replace the quantities. So instead of work we can use heat as well, my dear student. Why? Because the SI unit of work is joule and time is second, and the SI unit of heat is also joule. So instead of work we can write heat as well. So power is also called heat dissipated per unit time is called power. So write down power of a resistor. Power of a resistor. Write down power of a resistor. So power of resistor means how much amount of heat is dissipated by the resistor in 1 second. Write down the amount of heat. Power of a resistor. Our topic is power of a resistor. Power of a resistor. So write down the definition of power of a resistor. The amount of heat dissipated by the resistor in 1 second is called power of that resistor, is called power of that resistor. Remember, the amount of heat disappeared by resistor in 1 second is called its power, my dear student. How much amount of heat is disappeared by, as we know, resistor will be disappeared the heat. Disappear means waste the heat. So the amount of heat which is disappeared by resistor in 1 second is called its power. And the formula of power is nothing but heat upon time. Heat upon time. Now see, my dear student, the first formula of heat is H is equals to I square RT. If I take T in denominator with H, so H by T is equals to I square R, and we know heat per unit time is nothing but power. So one formula of power which is disappeared by the resistor is called I square R. Moving forward, my dear student, next formula for heat is H is equals to V square by R into T. If I take T in denominator with H, then it will be H by T, which is equals to V square by R. We know that heat per unit time is nothing but power. So power is equals to V square by R. This is the second formula which is represents as power disappeared by resistor, which is V square by R. Now see third formula. The third formula of heat is H is equals to VIT. Take T in the denominator of H, so H by T is equals to Vi. Now see, heat disappeared by resistor per unit time is nothing but power, so power becomes equals to Vi. So we have three different formulas of power. Remember, power is nothing but the amount of heat which is disappeared by resistor in 1 second is called its power. The amount of heat which is disappeared by resistor in 1 second is called its power. So we have three different formulas of power. First is heat upon time, second is P is equals to I square R, third is V square by R, and fourth is Vi. So remember, I is current across the resistor, R is resistance of the resistor, V is potential across the resistor, R is resistance of the resistor, V is potential of the resistor, and I is current across the resistor. Now write down next topic. Write down, my dear student, power developed by the battery. Power developed by the battery. Remember, battery will develop the power and resistor will disappear the power. So write down power developed by the battery. 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 So our topic is power developed by the battery. Power developed by the battery. Remember, resistor will disappear the power and battery will develop the power. So let's suppose we have a battery. When we are studying power developed by the battery, my dear student, we are considering ideal battery. So let's suppose a battery is there whose potential is E, and this battery is connected with an external resistor of resistance R. There is a battery whose potential is E, and this battery is connected with an external resistor whose resistance, my dear student, is R. Now see, as we all know, if we have a resistor which is connected across a battery, then the resistor can draw current from the battery. So let's, as we know, instead of current we can use charge as well, my dear student, because we know that rate of flow of charge with respect to time is nothing but power, is nothing but current. So instead of drawing current, let's suppose the resistor can draw Q charge from this battery. So write down, let Q charge is drawn, let Q charge is drawn by the battery. Let Q charge is drawn by the battery. So let's suppose Q charge is drawing by the battery. So we know that charge always flow from higher potential to lower potential, that is from positive terminal to negative terminal. I am writing here, let Q charge is drawn by the external resistor from the battery. Now see my dear student, we know that power is nothing but rate of doing work with respect to time is called power. We can also use this formula as well, dw by dt, it is rate of doing work with respect to time is called power. Now see my dear student, this external resistor can draw Q current from this battery whose potential is E. So work done by the battery. Remember, if we have a battery whose potential, let us consider the potential of battery is V. So work done by the battery, there is a formula, W is equals to Q into V. Remember this formula? This is the formula is work done by the battery. Work done by the battery is Q into V, where V is potential of the battery, Q is charge which is given by the battery, Now let's put the value of W here, because we are considering the topic as power developed by the battery. So let's suppose I'll put the value of W here. So P is equals to W is QV. Now see my dear student, Q is basically charge and V is potential. We know that if we have a battery whose potential is V, then we cannot change the potential of the battery. So V is nothing but constant. So we know that constant comes outside from differentiation. It is d over dt and Q. We know that dq by dt is nothing but current. So power developed by the battery is VI. Remember, the power developed by the battery is VI, where V is potential of the battery and I is current coming from the battery. So this is all about, remember, two formulas are there. One is work done by the battery. So work done by the battery is nothing but Q into V, that is charge into potential, and power is also write as rate of doing work with respect to time, that is dw by dt. So instead of W I'll put QV. So what we'll get? P, V is potential of the battery, which always constant, it comes outside. So dq by dt, and we know that dq by dt is nothing but I, because I is rate of flow of charge with respect to time is called current. So dq by dt can be write as I. So power which is developed by the battery comes to be VI. Now write down next topic, it is maximum power transfer theorem. Maximum power transfer theorem. Write down next topic, maximum power transfer theorem. Let's check it out, what actually maximum power transfer theorem is. So my dear student, very important topic, very important concept. It is maximum power transfer theorem. Maximum power transfer theorem. Maximum power transfer theorem. Maximum power transfer theorem. So see my dear student, what actually this topic is. Let's suppose we have a battery, practical battery, and we know about practical battery now. Practical battery carry two things. One is terminal and second is internal resistance. So let's suppose we have a practical battery. In this, the potential is E and internal resistance is R, and this practical battery is connected with an external resistor whose resistance is R. I am repeating once again. We have a practical battery whose potential is E and internal resistance is R. This practical battery is connected with an external resistor whose resistance is R. Now we want to know at which condition this battery can deliver maximum power to the external resistor. I am considering what is the basically condition on which this battery can transfer maximum power to this external resistor. Write down, we wish to find the condition, write down, we wish to find the condition on which, we wish to find the condition on which, we wish to find the condition on which this battery can transfer, we wish to find the condition on which, we wish to find the condition on which the battery can transfer, the battery can transfer maximum power to the external resistor, to the external resistor of resistance R, of resistance R, of resistance R. Now see my dear student, by Ohm's law we know that, by Ohm's law we know that V is equals to IR, so I becomes equals to V by R net. Remember this thing, Ohm's law says V is equals to IR net, so I becomes equals to V by R net. Now see, we all know that the resistor can draw current from the battery. So let's suppose this resistor draw I current from this battery whose potential is I and whose internal resistance is small r. Now see, in this circuit we have now two resistors. Remember, we have now two resistors. One is external resistor and other is internal resistor. Both the resistors in this circuit is working, my dear student. So remember, this is our external resistor, this is our internal resistor. In both the resistor, the value of current is same. In this resistor, current is I, and in this resistor also current is I. So if both the resistor carry same current, then we can say both the resistors are in series, because we know that if current across every resistor is same, then the resistors are in series. So now, as we know, both the resistor carry same current, so R net becomes equals to R plus R. So we'll get the value of current as I is equals to V. V is potential of the battery, and we know that potential of the battery is always equals to terminal potential, which is E. So we can write E by R plus R, because we have in this circuit we have two resistors and both the resistors carry same current. Moving forward, my dear student, now the power dissipated, let's find power dissipated by the external resistor of resistance R ohm. Power dissipated by the external resistor of resistance R ohm. We know the formula, it is P is equals to I square into R. P is equals to I square into R. Now put the value of I, it is P is equals to E by R plus R and its square multiply by, my dear student, R. So this is the basically equation. This equation shows power dissipated by the external resistor capital R, because we know that power dissipated by the resistor is I square R and the value of I is E by R plus R. So we'll put the value of I in place, we'll put the value of I in equation of power. We'll get power is equals to E square by R plus R and its square multiply by R. So power is equals to E square by R plus R square into R. Now see, my dear student, we want to find maximum power. Remember, there is a concept of math. If you want to find maxima or minima, remember, I am repeating once again. If we want to find maxima or minima, if we wish to find maxima or minima, then we have to differentiate the term and put it equal to 0. So here we have the value of power which is dissipated by resistor. It is E square by R plus R square into R, and we want to find maximum power. So for maximum power, we have to differentiate the equation of power with respect to change in resistor and put it equal to 0. So I am writing here, differentiate the equation of power with respect to dr and put it equal to 0. So what we have to write? dp over dr, and we'll put it equal to 0. Now we'll place the value of r. So see my dear student, d over dr, and the value of power is e square by r plus r square, and we have to put it equal to 0 into r and put it equal to 0. Now we'll use here differentiation method, which is division rule, and as I hope you all aware with division rule, my dear student. So let's apply division rule here. So what we'll get, just check it out. So division rule is, apply division rule here, apply division rule. So division rule is denominator square. I hope you all are aware with this. Denominator as it is, differentiation of numerator, minus numerator as it is, differentiation of denominator, and put it equal to 0, because we are finding maximum power transfer theorem, maximum condition for maximum power transfer theorem. Now see my dear student, as we are differentiating the power with respect to dr, so this E is constant, so it comes outside, so E square comes outside, denominator square, so we can write r plus r square and its square. Now see, denominator as it is means r plus r square as it is, d over dr, differentiation of numerator, minus numerator as it is, d over dr, differentiation of denominator, at that is r plus r square, and this is equals to, my dear student, 0. I hope you all understand this concept as well. So what we have to get beta, we'll get now E comes this side, so it will be 0, and dr becomes 1, so r plus r square minus 2 comes outside to 2r, r plus r. I hope you all are understanding this term beta, r plus r divided by r plus r raised to the power 4, which is equals to 0. So r plus r square minus 2r into r plus r is equals to 0. Now take this r plus r raised power 4 this side, so this becomes 0 again. So r plus r square is equals to 2r and r plus r. Now see, 1r and 1r get cancelled, so r plus r become equals to 2r. Let's take this r this side, so r becomes equals to 2r minus r, so r is equals to r. This is the condition of maximum power transfer theorem. See my dear student, the capital R is resistance of the external resistor and small r is resistance of the internal resistor which is present in battery. So write down in form of note, if the external resistor resistance, if the value of external resistor resistance, if the value of external resistor resistance becomes equal to the internal resistance of battery, if the external resistor resistance becomes equal to internal resistance of battery, then in that case battery can transfer maximum power to the external resistor. Battery can transfer maximum power to the external resistor. Battery can transfer maximum power to the external resistor. Now we know that the power disappeared by the resistor. We'll get, write down, power disappeared by resistor power disappeared by resistor, power disappeared by external resistor in case of maximum power transfer condition. In case of maximum power transfer condition, power disappeared by the external resistor in case of maximum power transfer condition. So we know that maximum power transfer condition means the external resistor must be equal to internal resistor. So my dear student, the power which is disappeared by the resistor is power disappeared by resistor is nothing but P is equals to E square by R plus R and its square into R. So instead of small r, we can use capital R because we are finding power disappeared by resistor in maximum power transfer condition. So E square by R plus R and its square into R. So power is equals to E square by 2R, R plus R is 2R and its square into R. I hope you all understand. Its square, R plus R is 2R and its square. So what we'll get? We'll get power is equals to E square by 4R square into R. So R and R get cancelled. So it is E square by 4R. This is the value of power which is dissipated by the resistor under maximum power transfer condition. Under maximum power transfer condition, it is E square by 4R. So I hope you all understand this thing. Very important concept is this, my dear student. If the external resistor of battery becomes, if the internal resistance of battery becomes equals to external resistance, then the power which is transferred by the battery is maximum, and the maximum power which is dissipated by the resistor is P square by 4R. I hope you all understand now. Moving forward, write down next topic. It is rating of electrical appliances. Rating of electrical appliances. Rating of electrical appliances. Rating of electrical appliances means to find the resistance of the electrical appliances. So write down rating of electrical appliances. Rating of electrical appliances. Rating of electrical appliances. Rating of electrical appliances. Write down, my dear student. Rating of electrical appliances means to find rating of electrical appliances means to find the resistance. Rating of electrical appliances means to find the resistance. To find the resistance of the electrical appliances. To find the resistance of the electrical appliances. Now see, my dear student, if you are aware with purchasing a bulb or just see the bulb, you will see there will be two different readings present on bulb, electric bulb. It is 100 watt 220 volt or 200 watt 220 volt. Means its power is 100 and it is operating with potential of 220 volt. All the appliances which is used in India is operating with potential of 220 volt. In different countries, the operational value of potential is, my dear student, different. In America, the potential is 240, 260 volt. In India, the potential is 220 volt. So basically, we know that power is V square by R. So R can be write as V square by P. So remember one thing, resistance is inversely proportional to power. If the power is more, then resistance is less. So remember my dear student, let's suppose we have a resistor or an electrical appliances. Let's suppose we have a bulb whose power is 100 watt and is operated with potential of 220 volt. Let's suppose this is A, this is B. Potential of A is VA and potential of B is VB. So we'll get the value of resistor with the formula, that is R is equals to V square by P. So V is 220 divided by P is 100. So R becomes equals to 220 into 220 divided by 100, 0, 0, 0, 0. So R becomes equals to 220 multiplied by 2, 0, 4, 4, 440 ohm. So this is how we'll get the value of resistance of any electrical appliances. This is basically what actually rating of appliances is. Rating means to find the resistance of the device. So my dear student, this is the end of concept heating effect of current. One more topic is there. So in next class we'll discuss that topic and we'll proceed with some numericals. So this is end of, in next lecture we'll end the theory portion of this chapter. So I hope you all are aware now with the chapter called current electricity. So thank you so much my dear student connecting with us. In next lecture we'll discuss some more topics and some more numericals. Till then, take care, be happy and study hard, make proper notes so that your concept will be greater. Thank you so much my dear student.